Okay, this is the same thing we had in the beginning of chapter 2. So right here it says, what's the opposite of addition? What's that?
Subtraction.
And what's the opposite of subtraction? So you can write those in real quick. So this one should be subtraction. And the opposite of the subtraction should be addition. And that's about it for the notes on this, other than the examples. It's the same thing we did in the beginning of chapter 2, except instead of having an equal sign in the middle, now we have an inequality symbol. And after we solve it, we have to graph the solution on a number line. So let's take a look at 1 and 2. Okay, so I have to get this x here all by itself, so what do? Yeah, good. Subtract 12 on both sides. So subtract 12 on both sides. So on the left side now, these cancel out, so I just have x. On the right side, I have 20 minus 12 is 8. And then I just bring down the inequality symbol. So just bring it down. Right now, it's a less than, right? So just bring down the less than. And then we have to graph the solution like we did yesterday. So you just put 8 there on your number line somewhere. And then open circle or closed circle? Open. And then shaded which way? Left or right?
That way.
To the left. All right. Let's do number 2. So again, we're trying to get the D all by itself here. So how do I get rid of that minus 5? Good. Add 5 on both sides. So again, these cancel out. So on the left side, I got D. On the right side, I got negative 7 plus 5. That's negative 2. And again, this is a greater than symbol here. So I just bring it down. So then I put negative 2 on my number line. I guess I could have circled that. And then open circle or closed circle? Yes, open. You only put the closed circle when it has the equal to bar. So it's an open circle, and I shade it which way? To the right, good. All right, there's 2 of them. Let's keep going. You guys good so far? Let's get number 3. All right, again, I'm trying to get the n by itself this time. So how do I get rid of this minus 0.3? Good. Yeah, just add 3/10 on both sides. So then on the right-hand side, these cancel out. So all I have is n. And on the left-hand side, I've got 0.9 plus 0.3. That's 1.2, good. And then I just bring that inequality symbol down the way it is. So right now it's a greater than or equal to. So I just bring it down as a greater than or equal to. Now these are one of the ones where I probably prefer it though if I wrote the variable on the left. So I'm going to rewrite this thing. So these are equivalent. So I'm going to put the n on the left side. And I'm going to put the 1.2 on the right side. And I put it pointing towards what? Yes. Yes, right now it's pointing towards n, right? So it's still got to be, so if it's pointing towards n, it's still got to be pointing towards n. Like that. All right, so that's our solution. And then we just put 1.2 on our number line. And then this one, open circle or closed circle? It's closed, it's a solid dot because we have the equal to bar. So we got the solid dot. And then which way do I shade it? Colton, what was that?
Right.
No, I mean, no, you had it right the first time. I just wanted you to repeat it, that's all. Yeah, so it's to the left.
So you shade it, so whatever.
Yeah, if you write the variable, Colton, if you write the variable on the left, this arrowhead right here will basically tell you which way to shade it. That says to shade it to the left. And it really says, these are the numbers n that are less than or equal to 1.2. So the numbers that are less than 1.2 have to be to the left. The numbers to the right of 1.2, they would be greater than 1.2. All right, and then what else we got? We got 2 word problems. All right, so let's try those. All right, this one says Shelly has a gift card. So her gift card is worth $30. So can she spend less than or equal to 30 or more than or equal to 30? Good. Yeah, it's got to be less than or equal to 30. All right, and then she's already spent $14. Plus, we want to figure out how much more can she spend. So let me just solve that inequality. So what do I do?
Subtract 14.
Good. Thank you, Dewan. Minus 14 on both sides. And I get x. These cancel out on the left. So on the left I have x, on the right I have 16. And I just bring down my inequality symbol, which was a less than or equal to. So again, I just take this and I write it the same way. So we wrote the inequality right here. We solved it right here. It says, what does the answer mean?
She has less than or equal to 16.
Yeah, she can spend up to $16, right? She can spend, $2, $4, $6, $8.50. As long as she's less than or equal to $16, she's got it, right? All right, the next one, kind of the same thing. This one right here, it says Mrs. Culver is at an auction. She will bid no more than $550. So then how do you write this right here? Oh, I actually messed you guys up right there. It's got to say no more than, right? No, that's good. Yeah, no more than 550 is less than or equal to 550. That's it.
Are you raising your hands or can you just say it?
Kind of both. So that's a less than or equal to. So same kind of setup again. So we got less than or equal to $550. And then she's already, well, she didn't bid it, but the highest bid so far is $475. That's right here. Plus whatever additional amount she's willing to bid, where she bids no more than $550. So if we solve this, we're just going to subtract 475 on both sides. And we get x is less than or equal to, what is that, 75?
Yes.
And then it says explain what does that mean? Well, that's the highest bid so far is 475. So Mrs. Culver is willing to bid no more than an additional $75. So that wrapped up 3.2. So let's move on. Let's do 3.3. You guys good with that so far?
Yes.
Okay. All right, so now this one starts out with the same kind of questions again. So what's the opposite of multiplication? What's that?
Division.
Good. Thank you, Cameron. And opposite of division?
Multiplication.
Yeah, thanks. So you guys can write those in real quick. So this one should say division. This one should say multiplication. Again, so these look just like what we did at the beginning of chapter 2 again. They're just one-step equations using multiplication and division. So let's look at 1 and 2. Let me slide down here a little bit. If I can fit both of these on here. There we go. All right, we'll go with that. Okay, so the first one, I got to get x by itself. So I got to get rid of that 7 there. So what do I do? Yes. It's right now it's 7 times x, right? There's a multiplication right there. So the opposite of multiplying by 7 would be divide by 7. So we're going to divide both sides by 7. These cancel out and make a 1. So on the left-hand side, I've got x. On the right-hand side, I've got, what's negative 42 divided by 7? Dewan, what's that? Good. So negative 6. And again, just bring your inequality down. So right now, it's a greater than, so it's still a greater than. So then we put negative 6 on our number line somewhere. And then open circle or closed? Good. So it's open. Which way do I shade it? Good. All right, the next one. I'm trying to get the m all by itself. So what's the opposite of dividing by 3? Yep, so we're going to multiply by 3 in the numerator over here. And we're also going to multiply by 3 in the numerator on the left side, like that. And then what happens to these 3's right here? Good. So those cancel. So on the left side, on the right side, all I have is m. On the left side, I've got 3 times 2.4. Thank you. That's 7.2. And then I bring down my inequality symbol just the way it is. So right now, it's a less than or equal to. So it's still a less than or equal to. But again, you guys would probably prefer if I wrote the variable on the left. So these are equivalent. So I'm going to switch the m and the 7.2. So which should it point towards? Towards the m or the 7.2? Good. Yeah, right now it points towards the 7.2, right? Or correct, I should say. So it points towards 7.2. So when I rewrite it over here, it's still got to point towards the 7.2. So it's like that. Yep. So then we got to put 7.2 on our number line. And Noah already said it's a closed circle. It has the equal to bar. So we need the closed circle. And yes, it's greater than or equal to, so we shade it to the right. Is that good so far? All right, we got number 3 here, right? Let's do number 3. So number 3, we're trying to get that r all by itself. So how do we get rid of that 3/4 there? You could divide. You could divide both sides by 3/4, but then you'd have to do 12 divided by 3/4. What's the other thing you could do? You could do that, yeah. You could make 3/4 into 0.75 and then divide both sides by 0.75. That would work. But I'm trying to get some other way to get that 3/4 to cancel out. What could I do? Yeah. Yeah, good. Yeah, multiply both sides by 4/3, which is the reciprocal, right? So we're going to multiply the left side by 4/3. And we're going to multiply the right side by 4/3. And then what happens to the 4's over here? Yeah, these cancel out. What happens to these 3's? They also cancel. Because 3 over 3, that's 1, and 4 over 4, that's 1. So then I just get R on the right, on the left-hand side. But then on the right-hand side, let's put this 12 over 1 here. And then we want to multiply these fractions together. So you just multiply straight across the numerator, straight across the denominators. Or you could cross cancel first, and then when you multiply, your answer will already be reduced. So let's cross cancel. So 3 divided by 3 is what? That's a 1. And then 12 divided by 3, that's a 4. So now multiply straight across the top, you get what? Good. Multiply straight across the bottom, you get, good. Yeah, 4 times 4 is 16. In the denominators, you got 1 times 1 is 1. And then bring down your inequality, which was a less than. So it's still a less than. And let's graph that. So we've got, put 16 on our number line. And then open circle or closed circle. Good. So it's open. And then which way do I shade it? Good. Yeah, so all the numbers are that are less than 16. So those are going to be all these numbers over here to the left of 16. The numbers over here to the right of 16, they would be greater than 16. Just remember, on your number line, your larger numbers are to the right, your smaller numbers are to the left. So if it's more than, it's to the right. If it's less than, it's to the left. All right, now I think you got to flip the page, right? All right, so we got 4 more to go. But before I do these, let me show you some on the side over here. So if I draw, let's write something like 10 is less than 20. Is that true? Yeah. Now if I divide both sides by 2, I would have 5, and I would have 20 divided by 2 is 10. So then my inequality would still be a less than, correct? Because 5 is less than 10. But what if I divided both sides by negative 2? Well, then the left-hand side of this thing would be a negative 5, and the right-hand side, 20 divided by negative 2 is a negative 10. Now, which one's greater? Correct. That's good. Yeah, the negative 5 is actually greater. So if you think on your number line, so on your number line, this would be negative 10 over here. This would be negative 5 over here. This would be like 0 here. Yeah, so the numbers that are further to the right are greater. So negative 5 right here, that's greater than negative 10. So what did I have to do to this inequality right here? What's that? Yeah, I flipped it. Yeah, you flip the inequality symbol. So what I'm saying then is if you divide both sides by a negative, you got to flip the inequality the other way. All right? Now what about for multiplication? Let's say we multiply both sides by 3. So multiply this side by 3, multiply this side by 3. Now this says 30 on the left and it says 60 on the right. My inequality would still go this way, wouldn't it? 30 is less than 60. But what if that was a negative 3 instead? Yes. If that was a negative 3 times 10 would be negative 30, and 20 times negative 3 would be a negative 60. So which number is greater? Yeah, negative 30 is greater, so we'll go this way, right? So again, notice that you had to flip it. So if you multiply both sides by a negative, you have to flip the inequality the other direction. So that's the rule we're looking for, is that if you multiply or divide both sides of an inequality by a negative number, you have to remember to flip the inequality symbol in the middle. All right, so now that we went over all that, let's do these examples. So let's do 4 and 5. All right, so on 4, I'm trying to get that x by itself, right? So how do I get rid of that negative 12? Remember, there's a multiplication right there, right?
Divide it.
Yes, divide. By what, Cameron?
12 on each side.
By what again?
12.
Say it again.
Divide by 12.
Almost.
Oh,
Divide by what?
12x.
No, you had the right idea the first time. What kind of 12 is that?
Negative.
Yes.
Wow.
Yeah, so you got to divide both sides by negative 12. And then those will cancel out, make a 1. So all you have on the left is x. And all you have on the right is, what's 84 divided by negative 12? That's negative something. Thank you. Yep, that's negative 7. And then do we need to flip it, yes or no? Do we leave that as a greater than, or do we change it to less than?
Less than.
Yes. Colton, that's good. Yeah, we got to flip it, right? Because we divided both sides by a negative number, right? If we divide both sides of the inequality by a negative number, you have to switch the inequality symbol in the middle in the other direction. Okay, so then we put negative 7 on our number line again. Open circle or closed? Open. Shade which way? Good. Oh, we got what, 2 more to go? 3 more to go? Let's do 5. So we want to get that x all by itself. Right now it's divided by negative 3, so what do I do? What's the opposite of dividing by negative 3? Yep, so we got to multiply both sides by negative 3. So we're going to multiply this side by negative 3, and we'll multiply this side by negative 3. And then what happens to these negative 3's? Yep, those cancel. So cancel those. So all we have on the right-hand side now is x. On the left-hand side, we have negative 3 times negative 8. Yep, positive 24. Because we have a negative times a negative is a positive. So we got a positive 24 on the left. And then do I have to flip it? Yes. That's good, Dewan. Yes, I multiplied both sides by a negative number. Correct? If I multiply both sides by a negative number, I got to flip the inequality the other way. So instead of being a less than or equal to, it's going to be a greater than or equal to. But then this is one of the ones, again, where I'd rather write it with a variable on the left. So I'm going to rewrite this now. So I'm really not flipping this on this last step. I'm just rewriting it. So I want to write it with the x on the left and the 24 on the right. So it's pointing towards what? What's the inequality pointing towards?
Less than or equal to?
Well, I mean, is it pointing towards the 24 or towards the x? What I'm saying is, consider this to be like a little arrowhead. What's it pointing toward, the x or the 24? What's that?
The x?
Yeah, it's pointing towards the x. So when you rewrite it, because it's the same thing, right? I'm just rewriting it. It still needs to be pointing towards the x. So you have to write it like that. What do I do? So it's like that. I guess I got to circle my answers here. All right, so then we need 24 on our number line. And then you guys open circle or closed? It's closed because we have the equal to bar. So we make the closed circle or the solid dot. Which way am I shading? Good. Yeah, that's all the x's that are less than or equal to 24. We got one more? I wanted to show you how to check one of these. So let's use number 4 for that. So on number 4, this was our solution, right? We had an open circle at -7 shaded to the left. So I should talk about how you check one of these. So to check one of these, you need to pick a number from the shaded region. So what's a number over here in the shaded region? -10. That'll work, right? This is -7, so this would be -8, -9, -10. So let's test it with, or check it with x equals -10. Should be right there. So what do? You put -10 into the original inequality. So our original inequality was -12x is greater than 84. So then you take your x that you picked in the shaded region, which in this case was the -10, and you plug it in for x right there. So then that would say -12 times -10 has to be greater than 84. Well, what's -12 times -10? Guys, what's -12 times -10? Hang in there. We only got like 2 to go. What's that? Good, 120. So now this says 120. 120 is greater than 84. Is that true or false? Is 120 greater than 84? Yeah. So it checks. So that's how you check your answer. All right. You have to pick a number in the shaded region, plug it into the original inequality, and if it makes a true statement, then you know you did it right. If you pick a number from the shaded region and you plug it in the original inequality, if you replace the x with a number from your shaded region and you get a false statement, then you know you messed something up. All right, let's keep going. So number 6. All right, so number 6, I'm trying to get this t all by itself. So how do I get rid of that -2/3 there? Say it. Who said it? Kyle, was that you? No. Dewan, what did you say? I forgot. Yeah. Yeah, he said times 3 over -2. So you multiply by the reciprocal. So we're going to multiply this side by 3 over -2. So hold on. So for some reason I can't write all of a sudden. Hold on. All right, so we're going to multiply by 3 over -2. Like that. But I told you guys, when you put a negative in a fraction, I mean, yeah, that is the reciprocal, okay? The reciprocal of -2/3 is 3 over -2. But I told you guys, if you have a negative in a fraction, to actually put it in the numerator. So let's put the negative up here, like that. And then I got to multiply the right side by the same thing. So I'm going to multiply the right side by -3 over 2. Okay, kind of like that. Okay, so then what happens to these 3's over here? They cancel out and make 1, right? What about the 2's? They cancel out because 2 over 2 is 1, right? And the same thing here again, 3 divided by 3, that's also 1. So these are all going to cancel out. So 2's cancel, the 3's cancel. And then you do have a negative times, make sure you have that negative there, because you need a negative times a negative, because you want to come out with a positive 1t. So your left side now is just t. And then your right side, probably put that 4 over a 1. And then you can multiply straight across the numerators, straight across the denominators. Or you can cross cancel first so that your answer is reduced. So 2 divided by 2 is 1. 4 divided by 2 is 2. Now multiply straight across the numerator and straight across the denominators. What would you get? Straight across the numerators is 2 times negative 3. Good. That's negative 6. And that would be over 1 times 1 is just 1, right? Now, there was a lot of explanation that went into that one. Do we need to flip it? Yeah. Yeah, we multiplied both sides by a negative number, right? We multiplied by negative 3 over 2. There's a negative right here. Yeah, so if we multiply both sides by a negative, we got to flip the inequality the other way. So right now it's a less than, oops. Right now it's a less than. So we got to flip it to a greater than. All right, so there's our solution. And then we got to put negative 6 over 1 is just negative 6. So we got to put negative 6 on our number line. And then open circle or closed. Open. And then shade which way? Good. Okay, so we just got 1 to go, all right? All right, last one. So the last one is this one right here. All right, this says Jill has a $20 gift card. So then, is that going to be less than or equal to 20 that she can spend or greater than or equal to 20? Yeah, she's got a maximum of $20 to spend, right? So no more than 20. So that's going to be a less than or equal to. So it's less than or equal to 20. And then, what she got? She wants to buy these tubes of paint, and they cost $4.30 each. So if it's $4.30 for each tube, or $4.30 for every tube, or $4.30 per tube, what do you do? Is that add, subtract, multiply, or divide? Well, if it's $4.30 for each tube, and you have 2 tubes, what do you do with the $4.30 then? Do you multiply it by 2, or divide it, or add it, or subtract it? Again, if it says $4.30 each, or $4.30 per tube, or $4.30 for every tube, that is multiply. That's what I was looking for. Thank you, Cameron. Yeah, that word each right there, that tells you to multiply. All right. And then what do you want to call the number of tubes? What do you want to use for a variable? All right, good. So this other side of your inequality should say $4.30 times t. So there's a multiplication right there. Does that make sense? So if you bought 3 tubes, it would be $4.30 times 3. All right, well now we need to solve this thing. So how do we get t by itself? Yep, divide by what? Dewan, what was that? Yeah, by 4.3. So we're going to divide both sides by $4.30. So we're going to divide this side by 4.3. And we're going to divide this side by 4.3. These 4.3s are going to cancel out on the left. And we're going to get t is less than or equal to, what's 20 divided by 4.3? And you guys got a calculator out there? 4.65? Is that a round off?
No, if you want around, it's 4%.
Okay, I mean, is there more decimal places? Yeah. So yeah, when you divide that, you get a whole bunch of decimal places. We're going to round off at, what was it, Tom? 4.65? So, I mean, that's your solution to your inequality. Any number that's less than or equal to 4.65. But can you buy 65 100ths of a tube? Not unless you're going to rip it in half or cut it in half or something, right? Or cut it in pieces. So no, you can't. So so the solutions to this inequality, what I'm trying to say here is, for example, can you buy 2.5 tubes? No. So 2.5 is a solution to this inequality, right? If I put 2.5 in right here for t, 2.5 is definitely less than or equal to 4.65. Well, I can't buy 2.5 tubes at the store, okay? That's not unless I'm going to cut them in half, and they're not going to let you do that. So then, what about a number like -1? -1 is a solution, right? So -1, if you plug that in for t right here, -1 is definitely less than or equal to 4.65, but you can't buy -1 tubes, okay? So how many tubes can you buy then?
Less than or equal to 4.
Well, you can buy 4. What else could you buy? Could you buy 3? Yeah, you could buy 3. Could you buy 2? Yes or no?
Yeah.
Yeah. Could you buy 1?
Yeah.
Or could you buy 0?
Sure.
Yeah. Could you buy -1?
No.
No. No, so you can't buy -1. So that's your answer right there. So the number of tubes that look at the question. It says, what are the possible number of tubes that she can buy? Well, she can buy 4 or 3 or 2 or 1 or 0 tubes. You guys okay with that one?